What is up, Mathletes? Welcome back to the episode of Math with Dr. Math, and look at the time. It's time for the chain rule. Don't go anywhere. All right, Mathletes, so let's dive in here and let's see what the heck is this chain rule and when do I use it, right? So again, I'm gonna take some flashbacks. I'm gonna talk about some things that confused me when I was a student and looking at this chain rule. And I wanna make sure you don't make these same mistakes because this thing could be confusing if taught by the wrong person. Okay, so let's look at this. So we have this definition here, and one thing that this should be reminding you of is composite functions, right? Composition of functions. When you have one function and you plug it into another function, right? If you don't remember, don't worry. But let me kind of explain what's going on here. So what we're gonna look at in this video is how to take the following derivatives, right? And you'll do that last one. But we're gonna look at these derivatives here, and what you're gonna see is each one of these is gonna have like an inner function, right? An inner function, and then we're gonna have an outer function. So we could think of it as like one function plugged into another function, all right? So here, let's look at this first one. The inner function, if I were to take the derivative, let's just ignore the derivative for now, right? So if I look at this, the inside function, the inner function is 2x plus 5, right? That's our inner function, the 2x plus 5. And where are you plugging that into? Well, you're plugging that into our other function that's saying, you know what, take that and cube it. So our outer function is something cubed. And usually for our input, what we say is we just call it x, right, for our input. So what we're doing is we're taking this and we're plugging it in right here. So we're getting 2x plus 5 and then we're cubing it. And that's what gives us this new function here. So whenever I say inner function, this is what I'm talking about. And then our outer function is cubed, right? And that's gonna be helpful when we're looking at this chain rule. But right now, we're just getting practice, making sure you know how to identify this, because if you know how to identify the inner and outer function, this is gonna be so much easier, especially as these get bigger. All right, let's do a few more just to make sure you got it. So here our inner function, when we take the sign, is gonna be x to the 5th. So our inner function is x to the 5th, right? And our outer function is just sine of x. And so again, what would happen is you take this inner function and we plug it in here, and that's what gives us this entire thing right here that we're gonna take the derivative of. And this one right here, the inner function is the 5e to the x power. So we have 5e to the x power plus 4x cubed. So there's our inner function. Our outer function is the square root of x. And again, you could rewrite the square root, just a reminder, as x to the 1/2. All right. So again, rewriting a lot of these radicals is going to be very helpful. All right. So what we want you to do is, for this one, we want you to identify the inner function and the outer function and comment down below what your answers are. All right. So we could check our work here as a community. All right. So what are we going to be doing when we're finding the chain rule? So check this out. Once you identified your inner function, we'll call that g of x. So the inner function, all these inner functions, we'll call that g of x, and your outer function we'll call f of x, right? You can call them whatever you want. We're just giving them these names because in most textbooks, calculus books, this is what you see. And what we do is we take the derivative of the outside and you leave the inside alone, right? And then you multiply this by the derivative of whatever the inside is, the inner function, right? So what we're gonna need to do ultimately is take the derivative of the outer function and take the derivative of the inner function and plug everything in here. But instead of just plugging things in, I wanna walk you through the steps so you can see how easy it is, all right? So let's take a look, follow me. All right, so let's look at this guy right here. We're gonna take the derivative of this composition of functions, right? You have one function inside of another function, all right? So what we do is, let me write it down here. We have 2x plus 5 cubed. So when I take the derivative, I'll call this function capital F of x So when I'm taking the derivative, right, capital X prime, capital F of X prime, so when I take the derivative, what I do is I take a derivative of the outside first. So that 3 is going to come out to the front, and then remember, you drop your exponent down by 1. So notice, all I focused on was that outer function, which was that, before we called it x cubed, right? So this number, brought it up to the front. This, we drop it down by 1. And the inside stays the same. The inside stays the same. So if I were to think about this, right? I have the derivative of the outside, right? And the inside stayed exactly the same. The g of x stayed exactly the same, right? Because we called this our inner function. We call that g of x. And then this cube part, the x cubed, we called that f of x, the outer function, right? And then we said we're going to multiply this times the derivative of the inner function. So we're going to multiply this by the derivative of the inside. So the derivative of the inside is just 2. So that we're going to multiply by 2. And again, according to the notes that we just saw, we're multiplying that by the derivative of the inside. All right, so let's rewind this real fast just so you could see exactly what we did, right? So we took the derivative of the outside, so that 3 came to the front, bam. I dropped down the 3 by 1, so that gave me the 2. The inside stays the same. So this represented the derivative of the outer times the derivative of the inner function. So the derivative of this is just 2, right? So it's that easy. For those of you who like to be organized, let me show you how you could rewrite this, right? And you might want to do this because we all think differently, right? So this might help you. So I'll just say f equals x cubed. F prime, the derivative of that, equals 2x squared, right? Just kidding. 3x squared. And then the inner function, right, we'll call it g, is 2x plus 5. And then g prime is just 2. So according to the definition of our chain rule, right, this x cubed, right, that's what we have. We took the derivative of it, excuse me, this 3x squared, right, that's right here, 3, whatever our input is, squared. So that's this part. The g is in the inside, right? So our original g, boom, it's right here on the inside. And then times the derivative of the inside. What do we get for the derivative of the inside? 2. So we multiplied it by 2. So again, for those of you that like to find a formula and then plug everything inside, that works as well. But what I really want you guys thinking about is, all right, take the derivative of the outside, leave the inside alone, times the derivative of the inside, all right? So again, that's going to be our thinking moving forward. All right, let's do another example. All right, so let's do this again. And again, I'm going to lay out both ways for you. I don't like following rules. I like thinking about it. But again, some people prefer following the format from the properties and from the definitions given in class, right? So I'm going to show you both ways. All right, so here we want to find the derivative of sine, right, of x to the 5th power. So again, the first thing I want to identify is I have an inner function. This g of x is x to the 5th. So that's why we have g of x, which is our inner function, is x to the 5th. And then the outer function, right, which is sine, is, we'll call that f of x. Again, these names here, they don't matter, right? So we have our inner function and our outer function. So now we're going to lay out f of x, which is sine, and g of x, and now we know we have to take the derivative of each. So the derivative of sine gives us cosine, right? The derivative of x to the 5th gives us 5x to the 4th, all right? So now, right, let's think about only when we take the derivative of the outer, right? So here we're going to take the derivative of the outer, f prime, so which is cosine of x, but remember, our inside, our g of x is x to the 5th. So this right here represents when I talk about the derivative of the outside, right? So the derivative of the outside, the derivative of sine is cosine, But remember, you gotta leave that inner function the way it is. So this represents that right there, okay? But now what's gonna happen is I'm gonna multiply this by the derivative of the inside. And that's exactly what's happening here. So what I just showed you, this part right here, and now we're gonna multiply it times the derivative of the inner. And what did we say the inner was called? G of x. So what's the derivative of the inside? 5x to the fourth. So that's why we multiply it by 5x to the fourth, right? So this is kind of me breaking it down, but here's the way I like to think about it. And hopefully you'll find this to be much faster, all right? So again, when I'm doing these, what's the derivative of the outside? Well, the derivative of the sine is cosine. Boom. Leave the inside the way it is, right? That's pretty easy. Times the derivative of the inner function. What's the derivative of the inside? Oh, it's just 5x to the fourth. Boom, there it is. And so again, the way I prefer to do it is find the derivative of the outside, leave the inside alone, times the derivative of the inside, right? And we're done. All right, so let's do another example using that logic. Follow me. All right, so let's look at this derivative of the square root function here. All right, so let me add some notes to this because some of us, we might be a little rusty on our algebra. That's okay, right? That's why I'm here. So whenever we see a square root function, just a reminder, I could rewrite this if I wanted. This is the same thing as 5e to the x plus 4x cubed. And since I'm taking the square root of that, that's the same thing as raising it to the 1/2 power. So whenever you see like the square root of x, I'll write it over here. That's the same thing as x to the 1/2 power. So make sure that's in your notes. And again, make sure you know how to change radicals to exponential form. And I have videos to help you with that, right? So again, make sure your algebra skills are down solid, and that's gonna make all this much easier. And then another thing to remind you of is that when we take the derivative of e to the x, remember that's just e to the x. All right, just in case you forgot, because we're gonna need that in a few minutes. All right, so note the outer function is this square root function, right? And so this is the outer function right here. So I prefer to rewrite the square root function in this format, right? You don't have to, but I think it's pretty helpful, right? So when I take the derivative of this, remember what we're doing. We take the derivative of the outer. So this 1/2, look what happened. It came to the front. Then I take 1/2 and I subtract 1 from this. So that's where we get this negative 1/2 exponent, right? So we're just using the power rule. Look what happened to the inside. The inside stays the same, right? So again, all we did right here is take the derivative of the outer function, the inner function stayed the same. Now we're gonna multiply this, right, by the derivative of the inside. So let me do it piece by piece, just in case you're looking at this and you might get lost. So when I take the derivative of the inside, right, because I have a sum, right, I could take the derivative of each piece individually, right? So when I take the derivative of each piece individually, well, that 5, this is a constant. Remember, you can bring that constant to the front. So you have 5, and the derivative of e to the x, we just said it's the same thing, it's e to the x. So we end up with that 5e to the x. And the second one's much easier. The derivative of this, we bring down that 3. So 3 times 4, that gives us a 12. And then we lower our exponent by 1. And so you end up with 12x squared. So here we have the derivative of the inner function. So there it is, the derivative of the inner function. So again, in summary, boom, this represents the derivative of the outside. Leave that inside alone, right? It didn't do anything to you, times the derivative of the inner function. So again, just some quick notes. Make sure you remember all your derivatives. If not, get practice, and then make sure you're really comfortable with rewriting expressions, because just by doing a little bit of rewriting, man, it makes a world of a difference. All right, so before you leave, we have one practice problem for you. All right, Mathletes, so before you leave, number one, make sure you smash that like button, make sure to subscribe, and we want to know, what did you get here for the derivative? All right, and go ahead, remember when you're writing exponents in the comments, use the caret sign, right? It looks like a triangle missing the base. So I made that really ugly, but you know what I'm talking about. So again, let's say you're gonna have 2x cubed. I'm not saying this is the answer, I'm just saying if you were to write 2x cubed in the comments, remember 2x, do a little caret sign, and then cubed. All right, so comment down below. We want to hear from you. And again, hopefully this video is helpful. Don't forget to tell a friend, subscribe, like, and we'll see you Mathletes next time. Peace. All right, Mathletes, thanks for watching. And again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching, and we'll see you guys next time.